Hi everyone, and welcome to another walkthrough tutorial of how to use SkyCiv Structural 3D. Today we're going to be exploring an example of how we can model a silo structure. So something like you see on our screen here. It's a cylinder mesh structure. So we're going to also learn some of the meshing features, as well as performing an FEA on a structure like this to sort of get some internal pressures. We're going to use hydrostatic pressures, apply them to this silo structure, and review the results. So we're going to walk you through two different ways of building something like this, but predominantly focusing on how we can use the inbuilt modeling features of SkyCiv Structural 3D to build something like this completely from scratch. As a second sort of bonus way, we're also going to look at how you can use the Excel plugin for SkyCiv to generate a structure like this. It's particularly useful if you do a lot of these types of structures. You can start to build a sort of preset template using Excel to model and build models like this. So we're going to start with just the Excel version just to explore that a little bit. So I'm going to open up Excel, and this works on Mac or PC. And we're going to start by installing the SkyCiv plugin. So to do that, I'll just go Insert, Get Add-ins, and here I can just search SkyCiv. And you should see that there is a plugin there available. Now I've already got that plugged in, so I'm not going to bother installing that, but it's a simple one click and you should see this SkyCiv option open up for you. And here we have a few different settings, and we're just going to start by setting up. So we just click setup, and that'll create the template sheet required to collect all of the input and information that you need to construct your model using Excel. The other thing we're going to launch is the renderer. So the great thing with this plugin is you can visualize in real time the model that's being built through the Excel plugin. So I'll just start building some nodes just to give you a bit of an idea of what we can do with the software. And we're going to do something similar to what we're going to build in the through the software itself. So I'm just going to put in some nodes. We're going to create one meshed element. Put 0 there. I'm going to put my 0 there. 3, 4. So I'm just putting in the XYZ coordinates. Actually, that should be 18. 18. And we'll go 30 feet up in the Y. And we'll do 30, 0. Oops. So it should be 3, 0. So you can start to see your nodes taking place, and what this is going to do is do the sort of outside or one element of the silo, and then we're going to rotate it around. And we're going to do the same thing in the modeling software in Structural 3D, but just to give you a bit of an idea how the plugin works, obviously we can use the inbuilt Excel formulas to create these inputs. I also highly recommend using a sheet as a sort of a template where you can put in diameter, putting these numbers so that it becomes a little bit more parameterized, height, and then obviously you can use those to build in some of the values that are creating your nodes and your plates. And then we're just going to use those plates. So again, we'll open up the plates. So we can add a plate just as an example. And these are comma separated, so I'm just going to select each of these nodes and then combine that with a comma separate, and then continue to sort of build it that way. And then the fourth node. Okay, so I've done something wrong there. I've got the and sign. Yep, so it's just simply 1, 2, 3, 4. Just got to rotate. That should be 0, and that should be 3. And then we've just got to put in some thickness values. So maybe a quarter inch, material ID. And you can start to see how that's forming my structure. It's quite a large plate. The unit system would probably be in metric, so I just need to change the values to metric if I'm going to continue with that. and I think your settings are controlled in here, so you can just change the settings once you to whatever values you want to put in there. And the great thing with all this is that you can also export this model to S3D. So, say I built my whole silo structure in the plugin, and I've visualized it, I'm happy with it, I can then just click open S3D and that will generate the model and launch it in S3D for me. So that's a pretty good way to build silo structures, or any other type of structure that's quite repeatable, where you want to kind of parameterize your input, create one sheet that generates the model. Really simple to use, and yeah, hopefully that's a good time saver if these are very common structures that you build. And for the purpose of this tutorial, we're actually going to build this from scratch. So we're going to use the software inbuilt features. We're going to follow a similar process that we started to do using the Excel sheet, but we're going to do it all from scratch using the software. So I'm just going to start with a blank canvas here, and to sort of figure out the maths behind it, I'm just using a very simple spreadsheet here. So it's just got my diameter, and then what we want to do is create a segment and rotate that segment around the silo to create the base, or form the base of that silo, and then sort of build from there. So I've done just some quick calculations. I've just got a diameter variable, and then the number of segments that I want to break up my silo into, and then obviously just dividing 360 by that number to get the degrees per segment. And then with some simple cosine and sine calculations there, I've got this sort of the node locations, or the size of my initial element that we're going to create. So this is just going to be one small element, and then we're going to use that to build from. So we'll start entering those nodes in, and you'll see how that structure starts to form. So we're going to just add in these nodes. So we've got 3, 0, 3, 0, and we've got, I'll just copy these values. And this one, we're going to build this silo. We'll build, let's build it up in 30 feet up in the air. So I'm just going to copy those values, just copy these ones, and apply that. So quite similar to the plugin that we had, we've got some nodes. I might make that a little bit smaller so it's a bit clearer to see. And then what we want to do there is just create a plate. So I'm just going to Control A to select all those nodes, and then right click, add plate. We use that feature a couple times. And you can see you've got kind of one strip of the silo built. And that's what we're going to use to now rotate around to complete the rest of the silo. So I'm just going to hit Control A again. And what we want to do here is we want to use one of the operations, which is rotate. And we're going to rotate that 60 times, and the angle between the repetitions is 6 degrees, which we've calculated using this. And we're going to rotate it about the axis of rotation, which is just going to be the origin up in the y direction. So you can kind of picture a vector here at the origin, 0 to 1, and we're just going to rotate around that, which is going to be the center point of our silo. So if all that's correct, we should see something like this, where we've rotated around that center, and yeah, all the mesh plates should be joined. A good thing to do here is just run a quick repair model, and we can just see that this is showing as an issue. We're going to explore that a little bit later, but for now we don't have to worry about that. It's just telling us that all these plates aren't meshed, but we're going to mesh them in a future step, so we can ignore that one. But what I was looking out for is, are there any duplicate nodes? Are there any close nodes? Because that would tell me that we haven't done the rotation correctly. But in this case, there was no other errors. I can inspect these nodes. They look pretty clean. They look like each adjacent plate is joined quite nicely. So I think we can proceed with the next step. Now, one thing I actually forgot to do, so I'm just going to Control Z is we forgot to apply a pressure here, and since it is a silo, we're going to apply some hydrostatic pressures. So we're going to just right click this and go add pressure, and now we want to go advanced settings because this is a little bit more of a complicated pressure. Then we need these additional settings like the load distribution and the axis. So we're going to add a linear pressure. This is because usually with hydrostatic pressures, the pressure is a lot higher the further you go down. Obviously with more water adds more pressure. So we're going to change this to linear, which is a linear pressure. And then we're going to change the axis to the local axis because we want this pressure being applied into the plane or into the face of the plate, and that load direction would be Z direction of the local plate. A quick way to check this is just go local axis, and you can see that the plate has the Z axis, which is the blue line, into the face, and that's the direction we want to apply the hydrostatic load. The last thing we're going to do is just enter in the magnitude of that pressure. Now at the base, which is nodes 1, so node 1, we'll say a -1 kip force. At 2 we're going to have the same, -1 kip force. And at the top we're going to have a 0 force, sorry, node 4 would be 0. And I'm just getting those nodes from 1, 2 and 4 as these corner elements or corner nodes. So I'll apply that, and it should just give us a good idea of how those pressures are going to be applied to each of the segments on that silo. And that looks pretty good. I'm pretty happy with that. So now we can go back and Control A once again and rotate. So again, using the number of segments, the angle between the directions, and of course the axis of what we're rotating around. Okay, so now we have the structure built as well as the loads. So we've kind of done both of those steps in the one repeat operation. I'm just holding S and scrolling. That's how I can turn the loads on and off or scale the loads. Just a little bit of a shortcut. We can turn the local axis off. I don't think we need those anymore. And even some of these labels. Start to see what that structure is looking like. Okay, so we might want to add a plate to the base as well. We're going to do some spring supports at the base. So I'm just going to highlight all those nodes, right click and select add plate. So that's going to automatically put a plate there and use these outer nodes as the node IDs. And we do the same with the top as well. Add plate. So we've got a top and bottom plate. And then, yeah, in terms of the geometry, pretty happy with how that is starting to look. Now we're going to start meshing the structure when we're performing an FEA on a shell element. To get the most accurate results, you typically want to mesh your plates to make sure that you have enough elements within there to accurately calculate the internal forces. So I'm just going to hold Control and then select all these internal strips, and then right click mesh plates. Now I've got a few options here. I could use the unstructured quadrilateral, which is an automated one, or in this case they're rectangular strips, so we kind of know if we want to create a rectangular or a square mesh, we can manually put in the base and height divisions. So base, let's divide each strip by 2, and then let's try dividing it by 40 in the Y. So we'll run that. It's got a few plates to do, so it might take a second. Okay, let's just have a look. We'll just turn the nodes off just to get a little bit of an idea of what kind of mesh we're working with. It looks pretty. So turn one of these strips on so you can see the two. I mean, it's a little bit long. You might want to divide them by more, or likewise we can go the opposite way and just so we can just unmesh. It's very easy to mesh and unmesh. And let's try that again. Look for something a little bit more consistent. So we maybe just do 1 by 40, and let's see how that looks. Okay, that's looking a little better. Typically you don't want really long, slender elements. You want nice, consistent square mesh where possible. So that's pretty close. We could obviously work out the exact values, but for now I think that's a pretty good mesh to work off. And now we want to provide some support at the base. So we're going to actually first start by meshing the base. So I'm just going to right click. And in this case it's not rectangular, so we can't really use the structured quadrilaterals. So we're going to use unstructured quadrilaterals. And we're going to let the automated mesher calculate this for us. It's a lot more complex of a shape. So I've got some settings here I can play with, but let's just keep it fairly coarse. It'll pick up any internal nodes or members, but in this case there aren't any, so we can just go ahead with meshing. And I highly recommend using the unstructured quadrilateral for more complicated shapes, such as a circle, as we're seeing there. And yeah, kind of see that's been meshed for me. And what we want to do here is create a support on that plate. So we can either select all the nodes and say we want to do a fixed support for the base of this silo. I can just go supports, double click here, and that'll import all my nodes, and you can select my restraint code. So you could do something like that. That'll be fixed supports if we zoom in and see those. So it's all fixed at the base. But let's try something a little bit different. What we're going to do is select the plate, and we're going to select under supports the surface spring support. So this is sort of on grade. You might want to support your structure, it's just sitting on grade, so therefore we want to add some spring supports to represent that soil. And it's already picked up my plate ID, which I had highlighted, and we can put in the modulus of subgrade reaction. So obviously that depends on your type of soil and the properties of that soil. So I'm just going to put in 0.15, and you've got a few different types of spring supports you can add, but let's just do a linear support for now. Okay, so if we zoom in on those, we should see now they're all little springs supporting the base of the silo. And yeah, one thing I will do is just turn the support. Actually, we'll just highlight those supports. So the quickest way to do that is just you can highlight all those elements like that. And if I go supports, it'll automatically detect I've highlighted a range of different supports. So it's asking me if I want to multi-edit all those supports, which I do. So I will change what I'm trying to do here is just add some restraint in the X and Z directions. So by default, obviously the soil is providing some Y restraint, some support from the ground below in the form of this spring, but we're not really providing any restraint in the X and Z directions, so the structure isn't static. I'm just going to add some fixity restraints, we remove these degrees of freedom in the X and Z direction. I'm going to make them fixed so that the structure does have some restraint in those directions. So that's starting to take shape. Let's turn the nodes off. Let's have a little bit of a look. Move the supports off. So pretty happy with how that structure is starting to form. The geometry, we've added all the plates, we've meshed the plates, we've added some loads via the hydrostatic pressures, and then we've created some boundary conditions through the spring supports at the base. I could add another plate at the top, something like that, just depending on what my silo is doing exactly, but for now I think we can have a look at some analysis results and we're ready to solve. So when I'm ready to solve, I'll just hit solve here at the top. I have a few options, but let's just do a linear static analysis. It's asking me if I want to skip the auto repair, which I do. We ran a repair model earlier. It seemed fine. And okay, so it's asking me that the plate 62 is not meshed. So let's have a look at what that plate is. A quick easy way here is we can just Control F, plate 62. It's a really easy way to identify the plate that isn't meshed, or query your model for more information. So I'll just Control F. And we did actually add a plate to the top of the silo, so we'll need to mesh this if we want to include this in the analysis. So we're just going to select that plate, run the mesh using the unstructured. Okay, so now we have the mesh plate on top as well. So now we're ready to solve. Okay, and that's solved successfully. So if I had other load combinations, like I possibly might want to add some snow loads or some wind loads, I can individually add those load groups. We only added the pressure, the hydrostatic pressure, so we only had one load combination to review. And so I'll select that one, and then we can go to plates. It'll show my mesh and the original shape, and then I can go to displacement sum. It's usually a first sort of result I like to look at, because through the deformation I can usually get a lot of information out on whether my model has been built correctly. We applied a symmetrical force for the internal pressures, and so I'm seeing symmetrical deformation across the structure. So I'm pretty happy with some of those results, because, or in terms of the displacement, because I can see the structure has been built correctly. Turn my mesh on or my plate results off. So the mesh is usually a good one to keep on. And then by holding S and scrolling my mouse, I can sort of see how it's deforming, and that seems pretty logical. I had those internal hydrostatic pressures pushing outwards on those walls, and then sort of getting some stresses on the base of the silo where all that force is meeting some restraint through the supports. So that makes a lot of sense. And you see the soil kind of pushing back up onto the structure. So after a quick review of the model, it seems that we've done a pretty good analysis there. We have a whole range of different values, particularly around the stresses, to review, so we can sort of see these stresses on the structure at 1.28 KSI, which is quite light given the steel strength of this material, which we can go back and review. If we check materials, kind of skipped over this, but we were just using a structural steel with sort of yield strength of 36 KSI. And yeah, even the plate thickness, kind of didn't really review that, but plate thickness just by default was 1/4 inch, which you can obviously change and make your own. Quite handy to review the renderer too, just to make sure that what we've built makes sense in terms of the geometry. So we hope you enjoyed this tutorial. Feel free to leave any comments or questions below in the YouTube video. Otherwise, we hope this helps you build your silo structures. Thanks a lot.